Hey guys, welcome back to another video on Kubernetes. And today we are going to discuss about the several components of Kubernetes, which will be a kind of revision. As we have already seen these components in our first lecture related to Kubernetes, and then we will be doing some practicals related to pod, replica sets, deployments, and namespaces. So we have seen in our previous lecture that master node, that Kubernetes cluster comprises of two types of nodes basically, and one is called as master node and another type of nodes are worker nodes. So master node is basically a node which what you can say monitors or not orchestrate, which monitors or manages your nodes, and worker nodes are the one which perform the actions related to your uh, cluster, like whatever workload is there, it will be those processing or all the processing will be done or will be handled by the worker nodes. So we have seen that master node has several components, and as you can see that the first component is the kube API server. So kube API server is basically the front end for every request which comes to this master node, and it will validate the request whether it is a valid request or not. Once it is once it decides that it is a valid request, it will forward this request to the other components, like controller and so on. Now this kube API server act as a front end and all the requests will pass through it. So let me take an example. Suppose there is a request coming in for this master node to create a node or create a pod. So it will first validate that whether the request is valid or not and what kind of request it is, like post request, whether it is a put request. I think it's a post request, or I think put request, I'm not sure about it. So it will check that thing and then it will valid whether the request is valid or not. Then once it has validated the request, it will send that request to the scheduler. Then what scheduler will do, scheduler will schedule or check in the various nodes which are available, which can be the best possible node to schedule or what you can say to have that pod, sorry. And once it has decided that that particular node in which the pod should be created, it will schedule that pod in that particular in that particular node. Now once this is done, the further processing will be done by kubelet, that is a component which we'll see later. Then comes the controller. Once our pods have been scheduled on different nodes, then there are several controllers which are continuously monitoring these pods and several other objects, similar objects like services. There can be pods, there can be deployments, replica sets, all these things. So there are several other kind of controller. So what they will do is they will keep on monitoring these pods or pod services, which are basically objects. So if they find anything which is deviating from the desired state of that cluster, so suppose my desired number of nodes in the cluster, or the number of pods in the cluster is equals to 3, and by anyhow or by some means one pod dies, so it is the responsibility of the controller to bring our Kubernetes cluster into the desired state. So this work is handled by the controller. And finally there is a component called etcd. So etcd is basically a data store which is a key value store where all the data is stored in a key value format, and it acts as a brain for this Kubernetes cluster. So if we want high availability, or we want that our Kubernetes cluster should be stable enough, so we should always have a backup for this etcd, because it contains all the information about the state of the cluster. And etcd is the one which is what acting as a brain for this Kubernetes cluster. And if it finds if there are any changes to the pod, then those changes should be committed to this etcd database. Then only the change or the request will be marked as complete. So this is the these are the components, or the major components of our Kubernetes master node. Coming to the worker node, in worker node we have kubelet, we have not kubelet, not kubectl, let me correct it here, kubelet. So as we have already seen that kubelet is the component which is responsible for performing all the operations on the particular node, and anything that comes up, or any task which has to be performed on a node, is performed by the kubelet. So as we have seen in the previous example, in a few minutes ago, that whenever a scheduler schedules a pod in some node, then scheduler will just ask kubelet to create a pod in that particular node, but finally the operation will be performed by the kubelet to dispatch a pod in that particular node. So this is how the kubelet comes into picture. Then we have kubeproxy. So kubeproxy is basically responsible for maintaining the internal networking, or is responsible for the connectivity between the several pods within a Kubernetes cluster. And third component is the container runtime. That is like we have Docker, which is running, on the top of which this pod runs. So these, and there can be other runtimes like CRIO, and Docker is there, CRIO is there, and Rocket I think is there, which can be used as a what you can say as a container runtime. So these are the components which we have in Kubernetes cluster. If you want to read further about it, then there is always this detail are present in the official site of kubernetes.io. So let's go to the official documentation of Kubernetes, where you can read about every component you want. So we will go to documentation, and here we can read about what is the architecture of Kubernetes. And here you can see the Kubernetes components explained very what you can say in a very good manner, and you can read further about the several components of Kubernetes here. So I'm not going into depth. So if you want to go through this, so you can visit this site and you can search for Kubernetes architecture, and you will get lot of information, and the several other components as well, which I have not discussed, because then this video will be too long. And moving on further, we will be doing some practicals. So let's move on to practicals. So what we have seen right now is that pod is basically we have seen is a pod, and we have not seen replica set deployment and namespaces. So first we will see how to create a pod in a Kubernetes cluster. And before starting, before creating a pod, we would like to discuss a little bit information about the pod. So pod is basically the smallest unit in a Kubernetes cluster, and smallest, or we can say smallest component of a Kubernetes cluster. And if we go by the definition, we can search for pod in Kubernetes, and you will see that what is a pod means. A pod is a group of one or more containers. So here you can see that how we can create a pod. So I will just pick this up from here, this definition. And what I have done is I have just started my Kubernetes minikube cluster, which I have discussed in my first video, how you can create your own minikube cluster which contains one node, one master node and one worker node. So right now what I will do is I will just do or query my Kubernetes cluster for the number of pods it is running. So you can see I have these 4 pods. So what I will do is I will just create another pod, and I will make use of the file. So right now I don't have any file here. I will just create one file, my.yaml, and in this file I will just copy the data which I have picked from there, from the official website of Kubernetes. And you can see you have to take good care of the indentation here, because if there is any mismatch or wrong indentation, then the pod creation or the deployment of this pod will fail. And this file is also called as the manifest file. So right now we are working on a pod manifest file. I'm emphasizing on this because I'm echoing this thing because I was asked the question, what have you ever created any manifest file? So I didn't knew that this file which we are creating is itself called as manifest file. So just for your info, it's a manifest file. So let's discuss about the various major, what you can say, tags or the keys which should be present in your pod manifest file. So first information which should be present in your pod manifest file is the API version, and it is v1 as of now. Then we know what it is, then what kind of object it is. So it's a pod. Then we have some metadata which we can attach to our this object, and we have written here that name of this object is nginx, and then we have given some specifications. And in the pod, inside a specification we mention the containers which this pod will be containing. So as we have seen that our containers runs inside a pod, and a pod is inside a node. So node is the outer cover, then comes the pod, and in that pod we have the container. So we have the containers. So basically here we have just deployed one container, and right now I'm not going into detail, so I'm not mentioning any port here, so I will leave it. So you have these many components which are required for you to deploy this pod. So if now I want to deploy this pod, I can do kubectl -create -f pod1.yml, and you will see that this pod is running and it has started. Now if you want to see the details about this pod, so what you will do is kubectl describe pod and the name of the pod here. So you can see that this is the detail about your pod. So the name of this pod is nginx, which we have written in our pod.yml file. Let me open another window and open or view the detail. So you can see here you have mentioned the name of this pod is nginx. So this is the name of this pod. Then what namespace we have, as we can see that we have not mentioned any namespace here. So any object which is created without any namespace is always created in the default namespace, or there can be other way to set the current context or the current namespace to some specific namespace you want to, but that we will see later. But right now we have the namespace set as default, so it has been created in the default namespace. Then there is a priority, so we have not given any priority, so its priority is 0. Then we have not attached any labels to this particular pod, so this is none, nothing is there. Then you can see the status of this pod is running, and the IP has been assigned by the Kubernetes cluster to this particular pod. And then finally I would like to emphasize on this part, that is the image which we have given is 1.14.2, and it is saying container image this already present on the machine. So what it has done is started container nginx. First it has successfully assigned default nginx to minikube, and finally once it has created that nginx container, it has started it, and now our Kubernetes pod is running. So I will see again, and here you can see that our nginx pod is in the running state. So what we have seen here is to create a pod, we just did create -f and then the name of YAML file, and that was pod1.yml. Other way to do this, it already exists, so what we will do is we will just delete this pod and its name is nginx. And we have seen that for creating a pod we use create command. We can also use apply command, and both works same. So right now if you will do kubectl get pod, you will see that your pod has been created with the same file but with a different option, that is create and apply. Now let's play with this pod1.yml and attach some labels to it. So what we will do is labels, and then inside labels we can so it is always good to have a 2 space indentation in our YAML file. You can give it 4 spaces as well. So right now what I am doing is I am just keeping 2 spaces. You can keep as per your choice. So right now what I will do is I will keep 2 spaces indentation, and I will mark it as front end. So what I have done is I have attached one label to my container, and I want to have inside this pod I want to run 2 containers. So my another container which I want to run is suppose Redis, and image can be Redis. I don't know the specific version, so I will just mention it as Redis, and I will save it. And let's do get pods and delete this existing pod, because it will again throw error that the pod already exists. So let's delete this pod first, nginx, and now again use the same command which we used earlier, and now you can see that to get pods, if you can see that your nginx is running and it is in the creating state. Let's see again, now it is in running state. And let me do the same thing again, that I will describe this pod nginx, and this time you can see that the containers which are running inside this pod are 2. The first one is nginx and the second is the Redis, and the images which have been used to create this particular pod are nginx, and then it has pulled the Redis image and deployed our pods, deployed our containers inside this one pod. And another thing which is noting, which is not what you can say, which is worth noting is that we have attached one label. And if I again do pod one.yml, you can see that we have attached label name with the name frontend, and you can see now we have a label name frontend here. So that is all about the pod. Now let's move further, and the second thing which we are going to say is the replica set. So let's move back to our article. So for okay, let's wrap up pod first. So for creating a pod, we have seen we will use create command, then apply command is there, then another way to create any pod is simply kubectl run nginx -image is equals to nginx. This is the another way in which you can create your pod, and this is much easier way, because here you don't have to create any pod YML file, because it directly runs the nginx image, and it directly runs a pod with the image nginx for you, and need not any YML file for its use. So this is how we can create nginx is. So right now if I do kubectl get pods, you will see that we have two pods, and this is in creating state. So this is another way in which you can create a pod. For deleting a pod, you have already seen that there is a delete command to delete a pod. Apart from this, if you want to if you want to edit any pod for any information, like suppose for nginx 1 you want to add some levels to it, so you can simply do kubectl edit, and then here you can go to levels, and here you can add frontend to it simply, and it will be reflected in your running pod. Kubectl get pods, kubectl describe pod nginx 1 described pod kubectl. What happened? kubectl, okay, spelling is missing. So if I see here, then you can see now we have a level of front end which has been added to this pod, which we didn't have earlier, but we added it with this kubectl edit command, and it got added to this instance of the pod. But once this pod is down, this will be gone with the pod itself, and we will have to again create a new pod. So here we have seen the several commands which you can use with the pod. So now if suppose your pod goes down, then there is no mechanism in the pod to get or to recreate itself. So for that we have replica sets, and whenever in production environment we deploy any pod, so we don't deploy it using the pod, but we use the replica set concept to deploy those pods, because then it automatically takes care of the pod which goes down and restarts those pods. So if I now let's see how to create replica set manifest file. So in the replica set manifest file, let me show you another way in which you can create replica set. So kubectl -help, I think that kubectl config logs certificate column expose create run set explain. Okay, this is another way. If you don't want to visit the official website, you can also use this command. So here you can see kubectl kubectl explain replica set gives you some information with which you can start. And here you have seen that version here which we are mentioning is mentioned as apps/v1. so this will be the version. Then you know that for kind it should be in the small letters. The Kubernetes does not take care of the case in which you are writing the YAML file. So you should be very careful whenever we are writing any YAML file, and it should be as mentioned in the Kubernetes documents, because if we are not using it in the correct case, it will throw an error. So you can see that API version is mentioned here, then kind is replica set, then we have the same as we have used, that we have the same field here also, that is metadata. And in metadata we can write anything we want. So let's suppose I am saying frontier, and let's finish it here. And in spec section, what we are going to do is we are going to mention the template, and here we don't have spec defines the specification of desired behavior of this. Let's go to this site, open this link. This is a spec ports, container port, objects, API convention, metadata, table of content, API convention. In that restrictions by convention, the state of my runtime, complete description.